In this video, ang pag-uusapan natin is kung paano natin ina-analyze yung ating mga algorithms. To start, pag-usapan muna natin yung mga issues ng algorithms. Unang-una ay syempre correctness. Tama ba yung iyong algorithm? Tama ba yung output na pinoproduce ng iyong algorithm? Time efficiency, yung speed, gaano kabilis yung pag-execute ng iyong algorithm. Space efficiency, gaano siya katipid pagdating sa memory, pagdating sa mga ginagamit nating variables and yung data structure. And last, optimality. Yun to yung balance ng time and space efficiency. So in this video or in this lecture, mag-focus lang tayo dun sa time and space efficiency. Kasi yun yung pinakamahalaga when it comes to analyzing algorithms. And in the analysis of algorithms, meron tayong dalawa. The posterior analysis and the priori analysis, if you can remember. Pag sinabi nating posterior analysis, this the empirical analysis ng algorithm. Ano bang ibig sabihin nun? Yung algorithm mo, ililipat mo na sa preferred mong programming language. Then, execute mo siya. And then from that, makakuha ka ng mga statistics gaya ng running time niya and then yung space na required sa kanya. So, doon mo pag-aaralan gaano ka-efficient yung algorithm mo. Next is the priori analysis. Dito tayo magko-concentrate. Ito kasi yung theoretical analysis of an algorithm. I-analyze natin yung algorithm before the implementation, bago mo siya i-translate dun sa deserve or gusto mong programming language. For example, we have the following. If you have a formula for your running time, which is, ang ginamit mo is yung execution time ng basic operation, multiplied by the number of times na in-execute mo yung bawat operation, i-analyze mo ngayon gaano ka-efficient yung iyong algorithm. Remember lang na when it comes to priori analysis, yung efficiency is measured by assuming all other factors kagaya ng processor speed, ng operating system mo, yung memory mo, they are constant at wala silang effect doon sa implementation. Considering that we are talking about theoretical. Now, we consider the following example. Okay? Write a function that calculates the sum of all numbers from 1 to n. Having that problem, meron kang first algorithm, kagaya nito. Wherein, magde-declare ka ng variable na total, tapos maglo-loop ka from 1 up to n, and then i-add mo lang yung values ng 1 mo or ng I mo para makuha mo yung total. And then we have another algorithm in which ang gagawin mo lang, you have the following formula, the n multiplied by n plus 1 all over 2. Gamit yung dalawang algorithm, parehas nilang masasagot yung problem natin that calculates the sum of all numbers from 1 to n. But the problem, if you analyze those algorithms, how can we determine which one is the best? Iko-consider ba natin yung iksi ng line of codes or iko-consider ba natin yung number of operations na ginamit? Next, linear search. We have the following algorithm and then ito yung kanyang example array. Ang tanong dyan ngayon, how much time does it take to run this? Para masagot yan, pwede mong gawin yung posterior analysis. Gawin mo siya mismo sa preferred mong programming language and then execute mo. Saka mo machi-check gaano siya kabilis. Kaso ang problema natin doon, magiging machine dependent tayo. Depende doon sa machine or computer na ginamit mo, doon sa operating system niya, doon sa mga naka-installed sa kanya, sa memory. Ano yung result? Another problem is, how does its runtime grow? Ibig sabihin, habang lumalaki, dumadami yung mga elements mo, ano yung nagiging effect niya doon sa bilis ng algorithm mo? Having those questions, okay, para masagot yan, meron tayong tinatawag na Big O notation. In which, ito siya, itong graph na to. We have the time and then we have the data input. And then we have the particular graph. Mamaya isa-isahin natin yan. Una-una, pag sinabi natin Big O notation, O stands for the order of. Okay? We have the following formal definition. F of n is in the O of g of n if and only if there exists a positive constant and a positive integer no such that all the values of n is greater than or equal to the no, and the f of n is less than or equal to the constant multiplied by the g of n. Anong ibig sabihin nun? Basically, pag sinabing big O notation, it is used to classify algorithms according to how their runtime or space requirements grow as yung mga input natin is growing. Isa-isahin natin ngayon yung mga big O notation natin. We start with the big O constant, yung O of 1. Ito siya, yung diretsong line. When we say O of 1, describes an algorithm that will always execute in the same time or space regardless of the size of the input data set. Example natin, you have the following algorithm. Nagpiprint tayo ng first element of the array. Ibig sabihin yan, kahit gaano kalaki, kahit gaano kadami ang dinadagdag mong element mo, since you are printing only the first element ng array mo at 0, constant ang time natin. Okay? That is what we call the constant. Hindi makakaapekto yon sa time niya. Next, the logarithmic. Log n. If familiar pa kayo sa logarithmic when it comes to mathematics. It means that the running time grows in proportion to the logarithm of the input size. Anong ibig sabihin nun? We will have the following example. Binary search. Kung mapapansin nyo, pagdating sa binary search, hinahati niya yung array mo sa dalawa. And then, sinesearch niya doon sa lower bound and then sa upper bound. Ano naman ngayon ang ibig sabihin nun? Ito siya, yung O log of n. Pag sinabi kasi nating logarithmic, ito yung kabaliktaran ng exponent. So, imbis na dumodoble siya, we are dividing. You can review your mathematics. Ano nga ba yung logarithmic na tinatawag? Okay? Next tayo. The linear. Okay, ito siya. Yung straight. Familiar na siguro tayo sa linear. Yan kasi ang madalas na topic when it comes to mathematics, which is the O of n. Describes an algorithm whose performance will grow linearly and in direct proportion to the size of the input data set. Example natin, printing all the elements of the array. Ito lang yung ating algorithm. Pag sinabi nating linear, habang dumadami yung size ng array mo, nadadagdagan din yung time na kailangan niyang mag-execute. Okay, kagaya nito, printing. Kung 10 lang yan, definitely hanggang 10 lang. Sabihin natin 1 second per or 1.01 second para sa isang element, so you have 0.010 para sa 10. Kung magdadagdag ka, additional na naman yun, 0.011 and so on. So, yun lang po. Direct proportion lang yung ating input sa ating time. Next, quadratic. Ayan, n squared. Ito siya. Pag sinabi natin quadratic, represents an algorithm whose performance is directly proportional to the square of the size of the input data set. Kaya nga siya naka-square. Example tayo. Print all possible ordered pair. So, mapapansin mo, mag-print tayo sa array natin by pair. Bakit siya naging quadratic? Definitely, pag sinabi kasing quadratic, we are performing nested loop. Mapapansin mo, dalawa yung loop natin. May loop siya and then meron siyang for loop ulit sa loob. So, yan yung tinatawag nating quadratic. Okay, if you understand kung paano gumagana yung nested loop, definitely magigets mo paano siya pagdating sa algorithm. And then, meron din tayong tinatawag na cubic and tree. Hindi ko na siya sinama rito kasi definitely that is deeper nested loop. Kung meron kang 3 loop, cubic, kung meron ka pang 4, and so on. And then, last natin is yung exponential. Ito yung n dyan, or basically that is an O2 of n. Okay, kung mapapansin nyo kanina, sa mathematics kasi familiar tayo pag exponent. Okay, usually yung number yung nakalagay dito. Pero dito sa algorithm, okay, to differentiate between yung sa quadratic, we have 2 raised to n. It denotes an algorithm whose growth doubles with each addition to the input dataset. Ang best example natin dito is the Fibonacci number. Kung familiar kayo sa Fibonacci number, wherein the next number is the sum of nung first 2 numbers, okay po? Habang nadadagdagan yon, lumalaki. Okay? Halos doble yung laki nung input natin. So that is what we call the exponential. Okay. In big O notation, may mga tinatawag tayong certain rules. Unang-una, may tinatawag tayong drop the constants. Ano ibig sabihin nun? Apply natin sa actual algorithm. If you have the following algorithm, wherein nagpiprint tayo ng lahat ng element twice, kaya meron kang dalawang for loop dyan, pwede nating sabihin na itong unang for loop mo is O of n. Okay? And then the second is O of n. Kasi n nakadepende nga sa size kung gaano siya or kung gaano kabilis yung pag-execute niya nung printing. Pwede nating sabihin na since dalawang O of n yan, that is O2 of n. But in big O notation, we drop the constant. We can call this as O of n only. Another example, ito. In this algorithm, ipiprint mo yung first item, then yung kalahati ng item, and then magsisay ka ng high ng 100 beses. So, having that, pwede mong sabihin yun na una is a constant O of 1. And this one, you can call this as O NO over 2. Kasi we have divided the 2, yung size. And then, this is constant naman hanggang 100. So, this is O 100. Having that, pwede mong sabihin na itong algorithm mo is O of 1 plus N all over 2 plus 100. But since in big O, we drop the constant, tatanggalin mo lahat yung 1 to 100. This is only equivalent to the O of N. Okay? And another one is drop the less significant terms. Ano ibig sabihin nun? Sa natin example, we print all numbers, then all pairs sum. We have the following 1, and then 2, 3, tatlong loop. Yung yung isa naka-nested loop. Pwede mong sabihin this is ON. And then yung naka-nested loop mo, ON squared. Having that, pwede mo siyang sabihin na this is ON plus N squared. But we need to drop the less significant terms. Anong ibig sabihin nun? Tatanggalin natin yung n, kukunin lang natin yung n squared. Why is that? Because may tinatawag tayong order of growth. So, pinakamaliit si O of 1, which is constant, followed by log, linear, and log, and then quadratic, and so on. Ibig sabihin, having the following equation, or O, big O, since meron kang n and n squared is bigger than n, kailangan mo nang tanggalin si n. Okay, ititira mo na lang, si n squared. Yun lang po. Dalawa lang itatandaan natin sa rules of big O notation. The constants don't matter and then the smaller terms don't matter. Example pa tayo. Kung meron kang O2n, tanggalin lang natin yung 2, this is only ON. Meron kang O500, this is only O of 1. Meron kang O15n squared, this is only n squared. Tinatanggal natin ang constant kasi habang lumalaki ang n natin, hindi siya ganun kalaki or wala siyang masyadong effect dun sa growth ng algorithm natin. That's why we drop the constants. Next, smaller terms don't matter. If we have 0 of n plus 10, this is only O of n. Okay? Kasi constant is lower than the n, the linear. Tatandaan nyo lang yung order of growth. And then, O 1000n plus 50, this is only ON. So, mas malaki ang 1000n sa 50 and take note that we remove the constant. Next, ON squared plus 5n plus 8, this is only ON squared. Kasi considering yan, ON squared ang pinakamalaki dun sa kanilang tatlo. Okay po? So, that is the rules or basic rules lang naman when it comes to big O notation. Last, may tinatawag tayong best case, average case, and then worst case pagdating sa algorithm. So, yung sum algorithm, it depends on the form ng input nila. Pwede nating sabihin na worst case is the maximum over inputs. Yung best case, the minimum over inputs. And then the average case is yung tinatawag na average. Pag sinabi nating average, okay, you take all the possible inputs and then i-calculate mo sila. And then, since average yan, okay, isum mo lang yon or i-add mo lang lahat and then i-divide mo lang kung ilan yung total number of inputs. But, in reality, dalawa lang ang kinoconsider natin sa algorithm. Yung best case niya and then the worst case. Paano ba natin malalaman? Example tayo, linear search. So, di ba familiar na kayo pag sinabing linear search? Isi-search niya yung element sa array one by one starting dun sa una. So, if you have the following example, ito, for example, ito yung array natin, and then ayan yung mga element niya. Ang best case natin is if ang value na hinahanap natin ay 23. Why? Because that is a constant. Nasa unahan lagi siya. And then, ang worst case natin, which is O of n, which is yung 67. Nasa last. So, ganun lang po. Every algorithm natin, we always have the best case and then the worst case. So, that is how we analyze algorithm. Okay? So, hope you understand. If you have any questions, just drop down doon lang sa ating group. Thank you.